Good morning, good afternoon, and good evening. A warm welcome to all of you from around the world. Welcome to this webinar on the use of Earth observation data and geospatial technology to support the decision-making in local municipality areas, provided by the South African National Space Agency. This is session 2, where we will demonstrate the use of QGIS for data analysis and policy making. I am Xingyi from the United Nations Office for Outer Space Affairs, and it is my pleasure to be the moderator today. Before we begin, here are a few administrative announcements. First, please switch off your cameras and keep your microphones muted throughout the webinar. Second, please type your questions and comments in the chat. You may do this at any time during the webinar. My colleague Rodrigo will be monitoring the chat. We will attempt to answer as many questions as possible during the Q&A session at the end of the presentation. Lastly, this webinar is being recorded. The recording will be available on the UNOSA YouTube channel after the event. Without further ado, let me welcome our trainers from SANSA, Thomas and Tando. You have the floor.
Okay, thank you, and then good afternoon once more, and then welcome back to the second session of the training. Basically, the second session is just a basic demonstration of practicals in terms of how to load data, how to do some basic GIS analysis. So, but first we'll just wrap up the initial training that we saw. The initial presentation on data integration, because of it also talks to what the current training will be focusing on. Okay, thank you, colleagues. Basically, when we talk to data integration, in the earlier on, we're talking to various data sets in terms of how they are aligned, the sources of those data sets, and then now then it's a matter of since now we have that data, what to look out to in terms of when you do data integration. First, data integration basically is just a combination of data set residing from different sources. It can be from a web-based data access platform. It can be from various sources. So in this process of combining spatial data from multiple sources and formats to create a comprehensive integrated data set for analysis and decision making, basically data set, it assists us in terms of making decision, considering all other factors, sort of like you are taking a harmonious approach in terms of how you analyze data so that you don't leave others behind. So you try to look at other factors that would affect, that could possibly affect other factors. So why data integration? Basically, you find that the data that you are getting from those various sources, they differ in terms of formats. So you find that the data, the projection system is not the same. Or let's say you are getting a data, and then you have to reproject it first before you can integrate it to other data sets. Sometimes the data in terms of quality is not that what you were looking for. And then some of the factors is due to revolution in terms of technology. Remember that sensors, in terms of resolution, they change over time. You find that over the years, we were used to using data which was at 30-meter resolution. Now you get fine data. In terms of spatial resolution, you find that it's even 0.5 centimeters. 0.50 centimeters. Basically, it means that the old ways, let's say the old ways where you used to analyze data is no longer suitable, meaning that now you have to upgrade. And then how then do you integrate that data set, which is coming from a very high resolution sensor with the data set that is coming from a very low resolution sensor? And then also what does it do is to create new possibilities for researching. Oh, my screen is moving, but so basically that is in a nutshell about data integration. And then the other aspect is to consider is what type of data sets that you'll be integrating into your into your analysis. And then also to enhance the analysis. Let's say you have vegetation data, or you have data in terms of temperatures, and then you don't know where people are located in terms of let's say you want to assess factors such as urban heat island and so forth. And then let's say you need water bodies as well to look at those temperatures, and you sort of like have an ecosystem of data to do your analysis. And then also querying the data. Let's say you have population data, you want to know where those people are in terms of spatial location. And then that is also some of the factors that you consider. So basically, these are the considerations that you should take into account before you do data integration. First, you need to determine the goal in terms of what do you want to achieve at the end of integrating your data system. Are you planning to create a data cube where people are just simply accessing data for and download it for their own analysis? Are you looking at creating a system where people will access data and do analysis at the go, such as your Google Earth Engine platforms? So what kind of data type are best for your user needs? So if you are looking at population data, or if you are looking at human settlement, what data do you need related to that particular type of data set? So which is the most appropriate integration technique for selected data? Remember, I told you that you find that data due to enhancement in terms of technology, you find that some of the data sets are not compatible. So meaning that the methods that you take into account in terms of making sure that that data is integrated. Resolution, you look at factors such as the metadata. Some of the techniques that you look at, because of the metadata, will basically tell you about the source of data, when was it produced, and then also it provides you with in terms of the accuracy regarding that data sets. And then what are the pre-processing steps that you need to consider after getting the data, and what is the best combination of that data? So these are the data integration features. First, you look at data compatibility, which looks at integration of all data set in terms of format. You have a shapefile, and then how do you integrate that shapefile with your raster data? Remember, earlier on, we spoke about raster data sets. So you look at those factors, and then how are you going to integrate those two data sets? You look at projections. In terms of projections, are the data similar in terms of projection? If you are working on the southern hemisphere, you find that you have to use a minus, and on the northern hemisphere, you find that you have to add a positive there. And then how do you integrate such data sets? And then are they aligning in terms of geometry? Because of sometimes there could be misalignment in terms of geometry, in terms of the data, and then you have to reproject that data set to make sure that they are aligning. Data quality, basically you look at the accuracy in terms of what are the errors that you are getting from that data set in relation to the data set that you'll be integrating to. Data harmonization, simply talks about aligning data across different sources that create a unified and consistent data set. I spoke about your GEE, and there are various other platforms which you find that if you integrate them together using your WMS files, you are able to take data from another source and integrate it into your GIS facility. Metadata, which is important for GIS data integration. So this, I already spoke about it. It helps you look at the source of the data, what is the quality of the data, and as well as the structure of that data in terms of how do you, when you're aligning your data set, you look at the structure, will it fit? And then you go back to issues such as the resolution. Are the resolution the same? Geometry, are they aligning? Data management, the best way to manage your data, and then tracking the changes over time. So these are some of the factors that I was talking about in terms of the features to look out to when you do data integration. Choice of appropriate data, metadata, content, scale, spatial extent, projection. What method was used to collect that particular data set? So those are the factors that you put into consideration. And some of the challenges when you do data integration, you find that the data that you are receiving from another source is of poor quality, but you are not aware of that. So when you are integrating it into your data set, it means that your results will also be affected. So those are the kind of consideration that you should take into place. Management of very large spatial databases. Basically, it means that when you're managing very large databases, it means that you have room to have more error in your data set. And then how do you counter against such errors? Data collection, data availability, and security risk in terms of some of the data when you are sharing it, you don't know who's receiving it, and then who that particular individual is going to be using that data for. So those are the kind of challenges that are there. So some of the techniques in terms of integrating data set is geocoding. Geocoding simply is just assigning geographic coordinates to a point. If let's say you have a points data, let's say you have a list of schools, but you don't have coordinates for that particular data set, it will not be easy for you to integrate the data into a GIS system. So you will need to coordinates. That's why you need to do geocoding. And then data media conversion, when you are digitizing all data set from paper maps or scanning, and then those are the kind of challenges that you also need to take into considerations. Data redaction, topology, rectification, and registration. Rectification meaning that you are rectifying your data, you're making sure that it's aligning. Image matching and image adjustment. For an example, sometimes you find that you need to enhance the resolution of your data set to visualize some of the features because of you find that the previous data set that was there, the resolution was very low. So we can use that as well to do that. Some of the benefits of data integration. So when you do data integration, it provides data to be easily available for fast connection between data stores. You can share the data from various sources, as I explained, to WMS files and so forth. So it's seamless data analysis and knowledge transfer to various users, better collaboration, meaning that when you are sharing data, as various users of the data, we have better collaborations. I understand, let's say, the southern part of Africa way better, and then you understand the other section of the globe better. And then that is also fostering collaboration. And then we can share some of the experiences in terms of how a particular data set is best suited for certain areas. So better, more precise information can be collected. Integration of GIS and remote sensing lead to synergetic approach to spatial data handling. And then remote sensing and GIS data integration is essential for many applications. This include land use planning, emergency management, environmental analysis, and infrastructure planning. And basically, at the municipal level, you find that they need to provide services to a community which is just closer to them. So you find that they know that, okay, we have a community which is situated there, but if they don't have the data set, they know that we have so many number of people, but they don't know the distribution in terms of how are they clustered across the particular municipality. Schools as well, and then as well as health facilities within an area. So they need to know that information. Health facilities, how many health facilities are available to support or to assist a particular area in terms of providing health services. And then municipality in terms of provision of services such as sanitation, they need to know where there is need. So using your GIS data, especially adding some of the spatial or non-spatial data on the attribute layer. It helps in terms of having more information about data. So another fact is that GIS can provide a comprehensive and accurate picture of of an area being analyzed, enabling better decision making, meaning that it raise awareness about an area, and then also integrating all those data sets. It also helps to identify challenges in certain areas and then come up with a suitable or better strategy in terms of mitigating those challenges. Okay, thank you. That is further reading, and then we'll go straight to the practicals. So basically, you find that on a quantum GIS functionality, there are various visions. So with each and every vision, you find that the toolbars in terms of how to do certain process gets updated. So you always need to keep up to date with what is happening regarding the development of quantum GIS. And then what I have with me here is a 2.8, and then there are other visions such as your 3.3, 3.2, depending on what you use, but the general essence is the same. So the data set that we'll be working on is what is displayed there. So from the file that we shared, you find that we have a folder which is written data1. And then from that folder, we have a raster and a vector and a spreadsheet. So we'll try to indicate to you, the audience, in terms of raster data after downloading your data from various data access platforms. Let's say you downloaded Sentinel data from Sentinel Hub. What are the things to consider? Because if you find that the data comes as a zip file, like what you see there, and then you need to first uncompress the data. Then how do you do that? So, and another one is a spreadsheet. It's a spreadsheet which is indicating a list of schools, and then we just removed other related information. But the essence is just to grasp in terms of how do you take this information and put it into a GIS system. Other part is vector data set, is various data set. You can, depending on your area of interest, you can add more data set. You can include your health facilities, you can include your police stations where there are locations, but for the training, we'll just indicate to you in terms of number one, we'll just indicate in terms of how do you upload data. Let's start with a spreadsheet. A spreadsheet of schools around Swane. The first thing that you do, let me exclude the other, is to check the format that that particular spreadsheet is stored. Which format is the spreadsheet? In this case, is in Excel. For it to be integrated or to be integrated into a quantum GIS system, first, what we do, we convert the file to a CSV format. You can see CSV, comma, delimited. And then let's see spreadsheet one. I'll just put one so that it varies from the previous one. Then you just ignore what is coming out. And then from there, after converting the spreadsheet to CSV, you can start uploading the spreadsheet into a quantum GIS system. To do that, I forgot to do an introduction. This is a quantum GIS system. It has various plugins, and then it has various toolbars and panels that you could use. For an example, if you want to access data from other sources, you can use your browser, and then you can upload your Google Maps. I will also come to indicate in terms of how do you create base maps. How do you install a plugin so that you are able to have base maps for data integration, or also looking at how good in terms of quality is your data set. And then going back to the spreadsheet, you go to layer, add layer, and then there are various layer adding functionalities there. We have add vector layer. It means that, remember, I spoke about a vector and a raster layer. If I'm going to add a vector layer, that is what I would use, add vector layer. And then if I'm adding a remote sensing image, I would use a raster layer. And then in this case, let's say I'm getting data from other sources. That is where you will add a WMS file. You will get a link from another source and you add that WMS file. And then in this case, we are adding a text layer. So we are going to use add delimited text layer. And then you browse to where you have stored your CSV file. Okay. So let me suppose we come here. Spreadsheet. So you can see that the Excel spreadsheet is there. You open it, and then after opening it, basically it will tell you the layer that you just uploaded, the encoding. If you interfere with encoding, you find that the data set is taking different shapes. Let's try, I don't wanna, there are various encodings basically, but for now, just stick with the default, because of if you interfere with it, it will somehow affect your data. And then usually on your system, you find that everything is unchecked like that. So you indicate there that you are using a CSV. Let's use a regular expression because the CSV is taking a different format due to encoding that is used there. And then you just choose a regular expression delimiter, and then you must add this colon there to indicate that you are separate. The data is separated in terms of colon since you stored it in CSV. If you open it on Notepad, you find that it is indicating that separation of data is in columns. And then you can see on the field there is saying field 1, field 2, field 3. But we don't want that. We want it to give us this information. So you just click on first record fields, and then you simply do away with those field 1, field 2, field 3. And then you have the data set as is the same way as is in your Excel sheet. And then in this case, we are adding points. So if we are adding points, then you need to choose your XY coordinates. And then if you look at my data set, because of you're working in the Southern Hemisphere, it said -25. So if you're working in the Northern Hemisphere, you find that you don't have that negative. We didn't touch presentation on coordinate system. You add your lines of your X coordinates in this case is your lines of latitude, and then your Y coordinates, which is your lines of latitude. You can also click use spatial index so that the accuracy becomes more precise, and then click OK. If let's say as in when you are editing your file, if you want the file to be continuous, for an example, to be integrated, when you are editing your Excel sheet, it edits on your Quantum GIS, you can click that watch file, but for the basic of training, we just add that. Oh, we forgot to do one thing. You can see that it's saying that our projection is not defined there. But in essence, you can add projection there. Let me just quickly demonstrate that. Because of for now, it has taken the projection of the window which I'm reusing. So you can add other data sets for the sake of time. And let's say you want to see if the data is overlaying with other data set which are already on our system. Vector City of Tshwane, and then let's add that. Open, and then you can see already the distribution of schools around the city of Tshwane. This area is just that there's no, it's just blank. Maybe people are not residing in that particular area, but based on that just visual interpretation, you can already tell where you would possibly find settlements. And then we add another data set. Say flood risk. So that is the layer that Rapula presented about earlier on, telling you about is indicating areas which are at, if it rains more than normal, let's say it's a 5 meter flood risk. If the areas are within that flood, within the 5 meter flood risk zone, they will be flooded. And then you add, what else do we have here? That one is for a different area. We add a raster. So we have to close this because of we are adding shape files. Add the raster. So we are adding the human settlement layer. API, which was generated earlier on. This is a type of raster data set, as well as, raster data set in the form of human settlement and raster data set in the form of vegetation. And because of after uploading this data set, you can see that you're not able to visualize those points. So you can play with your layer panels and use the drop down value so that you can easily visualize your data set. You can see those areas where I was indicating that you might find that there's no settlements. You can see that there are no settlements, and then usually schools are usually built where people are. So the other part that we have to demonstrate is the raster data set. A raster data set, remember, usually after downloading the data, it will come as a TIFF file, which is like this. And then you might have to download say WinRAR. Download any app that would you there are various apps for uncompressing the data. So let's download this one so that we can uncompress that data set depending on your computer operating system that you are using. Let's quickly just download this and and then, sorry, I was choking a lot. Basically, from there, you just install the software. And then after installing the software, now you can see that now the data is now clear. You can unzip the raster data set. So now the data is unzipped. The folder is empty. Let's try another one. Okay, now I'm supposed to extract this one. Apologies, I was supposed to extract this file which has data. And then from Sentinel, you find that we have various folders in there. There's a folder on metadata, and then there are various folders there. So you go to Granule, and that is where you'll find your images, and then you go to IMG data, and then there is the resolution of your data set. It is indicating 10-meter resolution data. So let's just add one data set into our quantum GIS system just for demonstration. You go to layer again. Remember, I already explained that in order for you to add raster data set, you need to go to add raster. Go again, Granule, IMG, and then you add your data set. So depending on your particular analysis, that is how you can add your data set. Let me just also add this one. So you can see after adding the data set, because of the data the bands are individual. Remember when I was talking about spectral resolution, when bands are not combined, you find that it doesn't give you color. If you were to combine the bands together, then it will give you color. You can see this one is a stacked image, which comes together with the data set. You can load it. And then after doing a stacking, in terms of doing stacking, you go to time. Okay. So due to time, but basically that is what you would see. And then from the image, you can start checking your settlements. Let me just push this one down a bit. And then you can look at how the data visualizes and then how is it distributed on the image. And then the good thing about acquiring image, if let's say settlements are changing over an area, you'll be able to identify them. And then sometimes there are other forms of the collecting data from a GIS. You can digitize the image. So I will not do that exercise due to time. So to digitize, you just create layer and then you say new shape files and then you draw. If it's a polygon, you will choose from there that, okay, you are actually digitizing a polygon or so forth. If it is a line, then you will choose a line. And then from there, you will start drawing on the map, as in when you are drawing using a pen on your book. So this is an example of some of the data integration, but due to time, some of the steps we'll share on the manual in terms of how to load data from other sources. Okay, let's do digitizing. I think we still have an hour to do the analysis. In terms of digitizing, basically for your digitizing to be accurate, you will need a high resolution data set. But for demonstration, let's just do basic digitizing. Let's say we digitize, let's see. Let's digitize, points. Let's say you want to point out police stations in an area, but you don't have a data set for that. So you go to layer, create, new shapefile. And then in this case, I will select points and also the projection that you'll be using. In this case is UGS 84. And then depending on your area, that is how you determine which projection system to use. And then you give it a name, let's say police stations. And then from there, because I've chosen a point, then I will just say, okay. And then it will bring out a save file in terms of what is the name of the file that I'm saving, police station. Save. And then from there, you can see that there's a point there, written police station created on the layer panel. And then for me to start digitizing, I need to edit the layer. On the layer panel, there's a toggle bar there with an indication of a pencil. You just click that, and then it will activate other features there. Since I'm collecting points, everything is done. It's on edit. And then we'll just select, what is it, this feature? Add feature, meaning that we are adding data set, we are capturing data. Let's say there's a police station here. You just go there and click in that area, and then you can give it a name, and you can say that that is ID is your first point, and then you can add other attributes after that. And then to add other attributes, right click, open attribute, and then from there on those toolbars on the top, you just say new field. And then and give it a name, say name of police station. And then since the data now you want to give it a name, you have to save it as a text file. If you save it as a string or as a whole number, it will not allow you to say to type in your. And then you can also demarcate the length, the number of words or of letters that should be used in that particular attribute file. Let me say melody. And that is how you capture data. If you want to add other fields, you just do the same process. And then another one, and then after that, you have to save the layer. To save the layer, you can double click on that editing and then say save police station. Remember, the data is saved. Then you can add other, even if let's say you want to identify health facilities, and then you find out the old data set doesn't have new developments. Let's say there's a new school which is developing an area, you want to capture that. You can edit the old data set and then add what is missing there. What is the other one that I'm getting? And then you do the same process with lines. You do shape files, new shape files, and then you add lines, and then you indicate the projection system, and then you continue doing the same process. That is in a nutshell for data integration. And then from there, that is when you can start doing your query analysis, of which that is part of the next session. So we'll load the manuals as well so that we can do a follow-on training. But otherwise, some of these exercises that you see here, you can just check them online. You'll be able to do some of the basic loading of data on a quantum GIS. Thank you.
The next session will be looking at situational analysis for decision making. Just to state why we opted to do the digitizing, it's because digitizing is the simplest way, which doesn't require too much computational abilities of your computers to do that. So it's the simplest way to just capture data. So the data that we're going to be using in the situational analysis, some of it will be from that. Some of it will be data captured through digitizing. Some of it will be data captured through image classification. For example, the human settlement layer, the HS 2023 dataset. So the dataset, the school dataset that you see there, is the dataset that was captured through digitizing. So we have the database for the whole country. Another dataset that is captured through digitizing is what we call sport building dataset, which is dataset which shows each individual house
Excuse me, Mr. Moapula, you are on mute. So you're just seeing your movie. Okay.
Oh,
I think
apologies.
Yes,
I've been talking. Yes, I've been talking.
Yeah,
I haven't been.
Can you start again, please?
Okay, thank you. So,
and sorry to interrupt again. And
no,
there's
no,
some
it's okay.
questions. There's some questions. There's some questions about the files, the data in the chat, and I'm not able to respond to these questions because I don't know how to handle it. So if one of your colleagues can see the chat, the last few questions about the files and answering the question, it will help us. Thank you.
Okay, so they will answer the question on the chat.
Yes, I see Tando Olifant answering.
Yes, okay,
So
no problem.
okay, thank you very much.
No, thank you very much for alerting me. But you can see the screen is being shared well. It's the QGIS platform.
Yeah, yes, I can
Okay.
see the screen. Everybody can see the screen, but the files, some of the attendees having problem to access the files. Okay, thank you very much.
Okay, thank you. Okay, so I was explaining that the reason why we demonstrated the digitizing process is because it is the simplest way of data capturing from satellite imagery. The data set that I'm demonstrating now, which is 20 SBC, this data set demonstrate all the individual housing structures, including those that are within areas that are not so easy to access. So using this data set, once you get, so you have an imagery over whatever area in your country or in your authorities, you get the satellite imagery, you can digitize, and then you can attribute within that all the different types of information that you want in terms of soft information, like, for example, access to electricity, access to water. If, say, for example, it census within that particular household, how many people are there, so on and so forth. So it's the simplest way, but other ways of mapping human settlement is through automated or semi-automated classifications, where you can run a classification on imagery covering your whole country, covering your whole continent, and then you get something similar to this data set, where the one which is showing in black and white, where all the individual building structures are automatically mapped, and then from this we're able to check growth. You can do calculation to see growth, where there's been growth in the whole country or in the whole continent, where a certain human settlements are informal, whether others are formal, where there are warehouses, where there are no warehouses. You can do this in an automated or semi-automated manner at a larger scale. But when you talk about locally, the process of digitizing has proven to be very much easier and simpler. It doesn't require a lot of computational abilities, so on and so forth. So with the situational analysis that we're going to do now, we're going to start with identifying, for example, the areas that are within an area that is at high risk of flooding. For example, the data set that occur in purple there, this is the flood risk layer that we have generated, the one that has similar information to that of a floodplain, flood line. Okay, so the one that is similar to a flood line, so it is able to demonstrate or show those individual housing structures that are within a what we call a flood risk area. And then with this, you are able to just use your simple selection tool to just select those individual houses that that are within the flood risk area. So you do something similar to that. You go to vector, you go to vector, you say research tools, and there are multiple tools for processing or analyzing vector data. Same with raster. These are different tools that are able to analyze any raster file. And then you can select, for example, select form. We say Swane sport buildings, and then where it intersect with the 5-meter flood risk, and then you say intersect, because on the intersect, those are the ones that are either overlaying or touching the flood risk. And then we continue. Then when you do that, then it will be able to select and populate all the individual housing points that are within a flood risk area. So if some of you may remember in my presentation earlier on disaster management, I talk about the flood risk profiling, where we are able to profile as to how many structures in one locality and even in the whole country that are within a flood risk area. We use a similar point, but the key thing is that one, there must be data set that is captured on individual households, and then when you superimpose that with the flood risk or the flood line, then you are able to pick those individual houses up. So when you have, for example, you haven't done the digitizing, you have done the automated or semi-automated human settlement layer mapping, which gives you a product similar to that of HS 2023, Tswane, the one which is only demonstrating the black and white colors. You are able to do the same thing, but the unfortunate part with that is that at first you will be able to show only calculate the area and the location of where those housing structures that are at risk of flooding are. However, you will not be able to count them one by one. So in this case, it's able to calculate one by one. To calculate one by one, you will have to perform additional processing on the human settlement base map, so that you are able to only identify the individual houses and also discard all the other inaccuracies which may have been classified also. So for that, because I'm seeing that my computer is giving me issues, I'm just going to terminate the process and just restart it. But in the meantime, if there are questions, please, I'm free to take any questions, and the team is also free to take any questions going back to the previous session as well. And another reason why we chose QGIS, it's free. Additionally, you can connect to different data sources, APIs. As you can see on the tile server, we have connected to Google Maps and Google Satellite and hybrids for those individuals whom in their respective countries they are maybe, for example, they don't have access to high resolution imagery, you can actually just import the Google Maps into QGIS, and you do the digitizing from that. The data will still be fairly accurate and very much usable in that case. Any question? If there are no questions,
Yes, there's no questions about the presentation. Most of the questions were about the data, how to get the data, the problems with the files. So just technical questions. Thank you very much for your presentation. But we don't have specific questions about the system and about how to use the system. Thank you very much.
In terms of the data that is giving us problem, we will just share a new link for the download of that specific data.
All right. Thank you very much for that information. And that's it. I think we have no more questions from our side.
okay. So since that the process that we ran earlier didn't run, but the results I ran it prior in anticipation of such technical glitches that often occur. Then you see the results are displayed on the screen where only the individual households that are flagged to be within a high risk area have been picked up. So the same thing can be done for the whole country, and then say if the required data set is available for the whole of the African continent, then we can do the same for the whole of the African continent. And to process on for something as big as the continental scale, there are platforms. There is Google Earth Engine. We are just not promoting it now because also it requires for space, you need to pay money to subscribe for the use of space on the on the Google Drive. And then also there are also other platforms, your Sentinel hubs. There is Digital Earth Africa as well, which are cubes that already have different satellite imagery, your Sentinel, your Landsat, and many others, where you can just run the various scripts and algorithms there, and then you compute whatever that you want to compute at that larger scale. Another situational analysis that we are going to do is a situational analysis for proximity of clinics. Where for that we're going to load data set on clinics. So with this, we are going to just demonstrate those clinics that are at a particular radius from settlements, or the settlements that are within 5-kilometer radius from the particular clinic. While I load the data, if anyone has questions, please do feel free to ask the question. Another important, very important aspect that our satellite imagery allows us with. If you look at the screen, you would see that there is a point which is located within a dam. Using satellite imagery is very much important also to clean the data, to see those data sets that are obviously falling off a particular area, because generally when we do data integration, we use data derived or collected by various users. For example, in South Africa, each and every um, department or organization is uh, mandated or tasked to collect data with relation to its mandate. For example, South African National Space Agency, we deal with satellite imagery. So the school data that is being displayed was collected by the Department of Basic Education. The clinic's data that is being displayed will be collected by Department of Health, so on and so forth. So it's various stakeholders or various users that are collecting various uh, GIS or spatial data set, and then you find that others have some discrepancies similar to this. And satellite imagery enables us to see such issues. So another, what we're going to do now, we're going to do what we call buffering. When we do buffering, that is when we search, we determine the radius of where, according to our legislation in South Africa, they say individuals or people must not travel more than 5 kilometers to get to a health facility, in this case, a clinic. Then we are able to use this buffering tool to identify those that the areas that are within but that particular distance. So to do that, we go to vector, and you go to geoprocessing tools, and then you say fixed distance buffer. The target layer that we're using is the clinics, and then we say the distance is there's something I forgot to do. Okay, now I see it. So before we do the buffering, if we go into the properties, you will see that the data is in Hartebius hook. The coordinated system is in Hartebius hook 94. Sometimes you will find it in being it WGS 84, and it's not in UTM. So when it's not in UTM, when it's in degrees, decimal degrees, and not in UTMs, it will not allow you to do distance calculations. So which means that first thing that we need to do is to reproject the clinic layer, and then come to vector. Then we define the projection. We go to the clinic, the output. We use UTM 35 in South Africa. And then anyone from across the world, you will be using the one projection that is applicable to your country or area. So in South Africa, we say UTM zone 35 south because we are in the southern hemisphere. Then we run it.
So, sorry, Moapula, you are on mute again. Yes.
Okay. Thank
And
you.
also, I'm going to use up this interruption, but someone is asking Miss Desmond Hamane to please show how to add Google Maps on QGIS. If possible, if you have
Okay.
some time, you can show to our attendees how to add Google Maps on it. Okay, thank you very much.
Okay. No, thank you very much. Okay, it doesn't look like it has finished running. In the meantime, just to answer that question while still running in the background, on the browsers panel, there is this button tile server. So this is where you are able to add any data from different APIs. So you just right click, you say new connection, and then it says enter the URL where the particular data is from. In this case, the Google Maps API. You can, to get the API, you just go to Google. How to import GIS. So it will show you that you can put it in as a plugin, or you can get that API. Just to save time, the API is already saved here. If we go to properties, it will show you this. I'm just going to copy it and paste it on the chart. That is I've pasted the link on the API, and then what you do is you just come to tile server XYZ. You say you right click on it. It says new connection. Then you say you add the new connection. You click on the new connection, and then you just connect to that, and then it will ask you give us the name of the data that you are sourcing, and I can say just test Google Maps. You say okay, then there it is. So what you do is that where you just double click on it, and then it will pull it from the internet, and then it loads it on that. So now the one that we selected is, it's not the satellite. Yeah, but it's loading. So on that, there are three of them. One is maybe the different types, and the one for satellite imagery, the link is there as well. So that's just how to, the satellite imagery one is this one. So this is the base map. Satellite imagery is this one, and then the satellite upgrade as well is there. But the same thing, you can get it from the internet. Thank you very much. Let me test if, let me check if And yeah, you can also use a plugin called Quick Map, where to use the plugin, you go to the tab plugins, you say manage and install plugins, and then you, on the search, you say Quick Map. Installed. It should be able to search for that particular plugin online, and then it will pull it up, and then you just install it. Okay. Zoom to layer. Properties. Now I'm just gonna search if it has reprojected correctly. Yes, it has. So now it says coordinate reference system. Okay, it says 72. That's not correct. It's supposed to be WGS 84. Okay, let's redo it again. We select the layer, you go to vector, you go to data management tools, you say define current, the clinic, it's supposed to be WGS 84, UT. S WGS 84 UTM zone 35S. Correct. Run. And then we check. Now it's correct. So it's within my country. It's in the correct location. Now we can do the buffering. Fixed distance buffer, and say we want it at 5 kilometers. And then you can save it to wherever you want it to be saved. Okay, that's incorrect. That's incorrect. It's a projection problem. Remove. So what generally happens when we do training online, sometimes things run smoothly, sometimes it creates a bit of problems. Okay, so the problem is the projection of this data set of mine seems to not be correct anymore, probably because of the first assigning of the projection. Let me load it again. Okay.
Sorry, Mopula, you are muted again.
Yes, because the process that we did when I had projected it to WGS75, it messed up the data set. So to 72, WGS72, I have to recopy it. So that we can rerun it again. And this is very important. Always when you're running this, always try not to use the original data. Try copy the data set and put it elsewhere so that in case the data gets corrupted or something, you are able to recover it. Okay. So now we have the correct data. It's in the correct area. And we're going to define our projection correctly. WGS84. And then we run it. Located in the correct area. Now projection correctly assigned, and we gonna do the buffering.
Sorry, you are muted again. I think you are pressing a button. Moapula.
Yes.
You are muted again, and I will hold this opportunity to say the link that we send again for the attendees about the files is requesting an authorization code. It's I don't know what happened in this time, but it's not possible to download the files again. So if you can.
Okay.
Right.
It requesting authorization.
Yes, it's like requesting authorization code and email. It's different for the first link you send. So if Tando can help us with this.
Is this problem experienced by everybody?
Yes, and I just tried, and for me to, the first link was okay, but this one is requesting an authorization code.
Okay, let me just quickly ask my colleague. I'll come back now.
All right, thank you. And if he can help and send another link without this authorization, and you can go on. Just you are muted again, so all right, thank you.
Okay. No, I was just discussing how to solve the issue with my colleague. So I just why I mute myself.
All right, thank you.
Okay, so what we want to demonstrate the results supposed to show us something similar to this. It's just unfortunate these things, computers generally, they act up. Where's no fail? Is it? So So with the settlements that we mapped automatically, we are using the results of the buffering, we're able to identify the settlements that are within the 5-kilometer radius of various clinics. The ones that are far, are outside that particular radius, we're able to see there. And again, we can also increase the buffer. Different countries have different standards. Say, for example, if your country, within your country, people must not be within, must not be outside 20 kilometers. You can increase that 20 kilometers so that you only see the settlements that are within that particular radius of a health facility or a school or so on and so forth, whatever service that's being required. And then in future, then the other planning can take into account the settlements that are outside that particular buffer. Another data set that is automatically being generated is the land cover. It's the land cover dataset. This is available for the whole continent. Landsat does have a land cover for the whole continent. Those who are from other parts of Africa. In South Africa, we generate our own that meets our own requirements. And also using this, we are able to see the different classification of settlements that are within a particular distance from the different clinics, and also all other land cover classes, which may or may not affect accessibility of the people in that particular area to the clinics and schools and so forth. So essentially, remote sensing is the tool that we can use to gather as much information as possible that is on the Earth's surface. If there are any questions, please feel free to ask questions. Has the authorization of the dataset been resolved?
Yes, they are talking about an email to check all the participants to check their email with the code. So they are working on this, but there's no specific questions from the chat for you. So I thank you very much for a very good presentation.
Thank you. For anyone who might be getting the Mimecast email, usually it's from your computer's protection. So if you just have to check on the email that you have used there to get authentication code, it's not from our side.
Okay. I don't think there will be another situational analysis for decision making that we're going to do. So far, we have done the situational analysis for flooding, flooding risk, and also for proximity to clinics that we have done, and we have done reprojecting. Even though there seemed to be a problem with my dataset. But yeah, so for the activities that we had planned to do for this session, I think we have done so. Please, any question, any clarification that you may be interested in? Okay. Okay, so I see people are able to see the data sets. It's just unfortunate it's so late in the, but with the manuals and everything, we hope and believe that everyone will be able to follow the manuals and redo these activities that we have been demonstrating to you.
All right, good. So if there are no further questions, I would like to thank all the trainers from SANSA for your dedication to capacity building in the use of EO data for climate action. And also a big thank you to all the online participants for your participation. So we hope that you have benefited from today's training and that you will be able to apply this knowledge to your research and project. So before we go, do check out our webpage for other trainings covering a wide range of topics from Earth observation data processing to business strategies on how to become a space entrepreneur. The link is provided in the chat. So thank you once again for your participation and have a good day.